Okay, today we are going to work on solving systems of equations by substitution. So our first objective is to solve your systems algebraically using the substitution method. And then once you have it solved, you'll determine whether your solution is one, infinite, or no solution. Okay, a system of equations is two or more equations. This is review. We've talked about this before. A no solution means that you have parallel lines, that the lines never intersect. The lines also have the same slope, but they have different intercepts. One solution is when two of the lines will intersect at exactly one point, and all that you have to notice about them is that they have different slopes. An infinite solution will occur when everything is the same. The slope is the same, the y-intercept is the same, the equation looks the same. Okay, for the substitution method, I will give you 4 steps. The first step is to choose a variable to isolate, which means to solve for in one equation. You're going to use what you have solved for in step 1 and substitute in to the other equation and solve for the remaining variable. So in step 2, you should notice that either all of your variables are x or all of your variables are y. If not, then you have substituted incorrectly. And once you have all of the x's in there or all of the y's, then you're going to solve for whatever variable you have. So at the end of step 2, you should have like x equals 5 or y equals 12. Then you're going to take that known variable that you just found and substitute it into either equation and solve. And that's your step 3. By the end of step 3, you should have an answer or a solution for your problem. So once you have that solution, step 4, you're going to check that solution for both equations. So our first example, it says solve using substitution. In this one, it's a lot more simpler than some of the other ones you'll see. You actually know what y is right here. Y is 3, so you have half of a solution. So you're going to take that 3 and substitute it into the y of the first equation. So it will read 3 equals negative 2x plus 4. And if you notice, you only have one variable to solve for now. So this is step 2. We've substituted into either equation and solved, or into the top equation and solve. So the first thing you're going to do is subtract 4. These 4's will cancel or subtract out, and you get negative 1 on the left side equals negative 2x. To isolate the x, you'll divide by negative 2. These 2's divide out. You get an x over here and a 1/2 here. So because y was already solved for, you actually have your solution. There's one solution at 1/2, 3. And what this means is if we were to graph these original equations, the y equals negative 2x plus 4 and the y equals 3, then we would see that they intersect at this point 1/2, 3. The last step that you're going to do is you're going to take those 2 points and substitute them in. In the bottom equation, we can only substitute y and we get 3 equals 3, which we know to be true. In the top equation, we get 3 equals negative 2 times 1/2 plus 4. So we get negative 2 times 1/2 is negative 1 plus 4 is 3, and it also checks. So we know that this solution is correct. Our second equation is a little bit more complicated, or our second problem. It does have y already by itself, so we're going to take all of this y, substitute it into the second equation, and it will look like this. 3x plus 2 times negative 2x plus 4. We've just replaced that y with the y from the top equation equals 1. And then if you notice, we only have x's in our equation, and we can solve this for x. So we get 3x plus a negative 4x, distribute this 2 to both, plus 8 equals 1. We'll combine our like terms. 3x plus negative 4x is negative x, or negative 1x, plus 8 equals 1. Continue solving, we'll subtract 8, and negative x equals negative 7. Because they're both negative, we can divide a negative 1 to both, or change both signs to get x equals 7. Now, we know one variable. This is all, we finished step 2. Step 3 says to substitute that known variable into either equation. And I think I talked about earlier, it might be easier to substitute it into one or the other. I'm actually going to go and take this value and put it right into this x of that equation. You could do either one, but this one seems easier to solve. So we get y equals -2. We're going to replace that x with what we know it to be. And we know it to be 7. And then we'll go ahead and solve this. -2 times 7 is -14 plus 4, which gives us -10. So we get one solution at 7, -10. And that means that those two lines, if we were to graph them, they would intersect right at 7, -10. The last step, I will have you check those. So we'll put them into the top equation. The top equation will read -10 equals -2 times 7 plus 4. And -2 times 7 is -14 plus 4 is -10. So it checks in the top equation. The bottom equation will have 3 times 7 plus 2 times -10 equals 1. This gives us 21 plus -20 is 1 equals 1. And we know that to be true, so that makes our solution correct. Okay, our last example that we have here, again, I already have a variable solved for you, but your first step would be to isolate a variable. It's been done for you. So we're going to take all of this and replace that x, and it will look like this. 3y plus 9, we've replaced that x, plus 2y equals -1. We combine these like terms to get 5y plus 9 equals -1. Subtract the 9. And we get 5y equals -10 divided by 5. And y equals -2. Okay, at this point you're going to take that value that you just found and isolate or substitute it into either equation and solve for that remaining variable. So I'm going to take the top one because it looks easier to use. And we get x equals 3 times the y we just found. And the y that we just found was -2. And we get x equals -6 plus 9. Add those together to get 3, which leaves us with one solution located at 3, -2. Again, that means that these two lines will cross and they will intersect at 3, -2. To check both of these in the original equations, we take the x and replace it with 3. So 3 equals 3 times our y value, -2 plus 9. 3 times -2 is -6 plus 9 is 3. So it checks in the first one. The second one, again, we replace 3 plus 2 times -2 to see if it equals -1. So 3 plus 2 times -2 is -4. -1 equals -1. It checks, so we know that this is the correct solution to this problem. Now we have some special cases. If I take this first equation and I go and I replace the x in that second equation, it should look like this. 2y minus 1 minus 2y equals 1. If you notice, these two y's will subtract out, and we're left with -1 equals 1. Now you have to look at this and decide, is this a true statement? Because -1 does not equal 1, then these two lines have no solution. That means they're parallel and they do not intersect. So if you find a place where your variables subtract out, you need to look at your final statement. So I take our second example again. We're going to go and replace this here into the x. So you'll have 2y plus 1 minus 2y equals 1. The two y's subtract out, and you get 1 equals 1. Here we have a true statement. So this means that you have infinite solutions, and they are the same line. Okay, I have this question down at the bottom. It says, can you solve 0 equals 3x? I do this intentionally because a lot of kids think that you cannot solve this. Well, you can. To isolate x, you would divide by 3, and 0 divided by 3 is 0. So you would get 0 equals x, and you do have a solution here. The difference between these two equations, as you look at the second one, can we solve 0 equals 3? No. We can't solve that. There is no variable, and this would indicate a no solution, where this one does have a solution. Okay, your last problem is a story problem, or your last example I have for you. You're going to read this. It says, Marianne sold 20 necklaces and bracelets at the craft fair. She sold 3 times as many necklaces as bracelets. How many of each did she sell? The first thing you need to do is determine your variables. So we're going to say B equals bracelets, and N equals necklaces. From here, you're going to set up your equations. Your first one says that she sold 20 of them. So altogether, N plus B will equal 20. The second one says she sold 3 times as many necklaces as bracelets. So she has more necklaces than bracelets. So we're going to say the necklaces is 3 times the bracelets. Now if you notice, here's our system. And we have in our second equation N already isolated. So we're going to take all of this value and replace that N and solve it. So you get B plus 3B equals 20. You combine like terms and you get 4B equals 20. Divide by 4 and divide by 4 there, and B equals 5. We can take what we know there with the B equals 5 and substitute it into that bottom equation right here for B. So you get N equals 3 times 5, which is 15. So from here, I want you to write a statement. We're going to say that Marianne, or she, sold 15 necklaces and 5 bracelets. All right, that should take you through it. Your assignment is your worksheet that I have provided for you. Good luck.